Now that your keys are protected inside Managed HSM, the next challenge is controlling who can reach it and how. In this module, we'll look at shrinking public exposure using private endpoints and DNS, and building secure least privilege application access with managed identities. So far, you've seen what HSMs are, how cryptography works, and how Azure protects key material. You compared Key Vault, Managed HSM, and Dedicated HSM, then deployed a Managed HSM and operated keys securely. In this next step, we'll lock down network access and private connectivity, then use that foundation as we move on to Azure Dedicated HSM. Managed HSM already gives you strong hardware-backed protection for your keys, but that alone doesn't stop an attacker who can freely reach your endpoints. By tightening network paths, you shrink the attack surface for stolen credentials, automated probes, and unauthorized API calls. Think of it as another layer in defense in depth. Hardware isolation, strong identity, strict network access, plus logging and governance, all working together to meet enterprise and regulatory expectations. Whenever an application or admin talks to a managed HSM, two gates must be passed. First, the request has to reach the service endpoint over HTTPS. Network controls like firewalls, private endpoints, or virtual networks decide whether that traffic is even allowed in. Then, Azure Authentication issues a token, and Managed HSM's local RBAC evaluates it to determine which key operations are permitted, such as read, sign, wrap, unwrap, or full key management. When you deploy a Managed HSM, the first major choice is how reachable it will be from the internet. Open public access is the simplest, but it also creates the broadest attack surface, which is unacceptable for sensitive or regulated keys. A safer pattern is restricted public access, where firewalls only allow specific source networks. The best practice is private endpoint access. Traffic stays on trusted networks, public exposure is removed, and any exception must be explicitly justified, monitored, and approved. Think of the firewall as enforcing a very small set of deliberate paths into your managed HSM. Allow only the specific application networks that truly need to call it, whether they're in the cloud or on-premises. Define a separate, controlled route for admins through jump hosts or secure workstations. Keep temporary exceptions clearly labeled and time-bound. Then review these rules regularly so only current, justified connections remain. When an Azure service needs a managed HSM key, don't assume trusted access will just work. Start by confirming that specific service actually supports managed HSM and how it connects through your firewalls and private endpoints. Decide which identity it should use and lock it down with least privilege RBAC rather than broad data plane access. Finally, document which services are allowed and for which scenarios so auditors and future teams can clearly see approved patterns. A private endpoint lets your managed HSM sit behind a private IP inside your virtual network. The service is still exposed through Azure Private Link, but traffic never traverses the public internet. Your applications keep using the same managed HSM hostname. DNS simply returns a private address instead. This gives you strong network segmentation, but it doesn't replace other controls. Clients still must authenticate with Microsoft Entra ID and have the appropriate managed HSM permissions. DNS determines whether your apps reach the managed HSM privately or leak out toward the public endpoint. Each client should resolve the HSM hostname through a private DNS zone that returns the private endpoint IP, and that zone should be linked to every VNet where consumers run. In hybrid setups, use split horizon DNS so on-premises queries forward into Azure and still resolve privately. Then verify name resolution from each workload subnet, not just a single test machine. Hub-and-spoke networking lets you isolate workloads while still sharing core services. Each spoke can represent a different environment or sensitivity level with its own private endpoint to managed HSM. You choose whether those endpoints reside directly in each application VNet or in a centralized connectivity spoke, as long as routing and DNS stay tightly controlled. The key is aligning these patterns with your landing zone standards, so access never becomes broader than intended. Managed identities let your app talk to managed HSM without ever handling a secret. You start by enabling a system-assigned or user-assigned identity on the Azure resource. Then you grant that identity only the specific HSM roles it needs, such as key reader or signer. In code, The app asks Azure for a token using the managed identity and uses that token to call the HSM. There are no hard-coded keys, and rotation becomes as simple as updating role assignments. For automation access, picture a ladder of options from most to least desirable. At the top are managed identities and workload identity federation. They're effectively secretless, reduce operational risk, and work well for long-running services, Kubernetes, and pipelines. Traditional service principals with secrets or certificates still have a place, but treat them as high-value assets. Scope them tightly. Separate deployment access from runtime key access, and never store their credentials in code, repositories, or images. Now bring this together across 4 common Azure workloads, all following the same security playbook. Virtual machines reach managed HSM over private endpoints and authenticate with managed identities. App services and functions integrate into a VNet so their traffic also stays private. AKS workloads use secure pod or workload identity, not embedded keys. Pipelines rely on short-lived or federated credentials that are tightly scoped. Across all of them, enforce private network paths, strong identity, least privilege, and thorough key monitoring. Before going live, treat your secure network as untrusted until it proves itself. Start by resolving every critical hostname and confirming clients receive the expected private IPs. Then walk the actual paths: admin to HSM, app to HSM, and monitoring tools to logs. Separately validate identity and RBAC, the correct principals, the least permissions, and no lingering temporary bypasses. Finally, watch logs for denied calls or unusual patterns, and avoid fixing issues by reopening broad public access. You've now seen how to harden managed HSM end-to-end. Restrict exposure with private networks and tight access rules. Design DNS segmentation and hub-and-spoke networking intentionally. And authenticate using managed or workload identities, not hard-coded secrets. Next, we'll carry these principles into a deeper, infrastructure-focused look at Azure dedicated HSM.